All right, in this lesson, we're going to begin Chapter 7, Section 1, where we're going to simplify trigonometric expressions. Okay, so you guys know most of these identities. You don't need to know all of them just because we're only really going to use the reciprocal identities and the Pythagorean identities. And then kind of another thing that you guys have seen before but haven't really used are these identities in the middle, the tangent equals sine over cosine and cotangent equals cosine over sine. We don't really need the even, odd, or the cofunction identities in this particular lesson. I actually don't think you really take full advantage of these until pre-calc. And even in, I think, pre-calc honors, you don't really do a lot with it. I think it's mostly like a pre-calc honors advanced kind of thing. But yeah, definitely we're going to use these a whole bunch. All right, so these identities. But the good thing about these is that you guys have seen these before. So I'll kind of explain what we're doing and then we'll get started with some examples. Okay, so the goal of simplifying. Sometimes you use substitution to simplify, sometimes you don't. But here are some of my tips to simplify expressions. In no particular order, is check if there's a GCF. That's usually for if you have something with like a plus or a minus in between. So if you have like a plus or a minus in expression, you would check if there is a common factor there. If there is something squared, you would typically check if you can use a Pythagorean identity. All right, you're going to take full advantage of those Pythagorean identities. And more often than not, probably like 90% of the time that there's something squared, you're going to have to use one of those identities. If you see fractions, like if you see anything that it's like an unlike fraction plus another unlike fractions, you would get a common denominator. All right, so see if you can get a common denominator between two unlike fractions. If you're stuck, you should change everything to sine and cosine. Change to sine and cosine. All right. And probably the most important thing that you should do is do something. All right, I say this in class. Do something, right? You don't just want to stare at it and wait for it to come to you. You want to actually try something because maybe there's something that you haven't seen when you started the problem, and then after you did something, it makes it a lot more apparent of what you have to do. Okay. So some of these examples are going to be kind of tricky at first just because this is completely new information. All right, so let's just start with this first one. Okay, so the goal of this, again, is to simplify, right? Now, in general, simplifying, it just means you're trying to make something easier, right? Trying to make something smaller. All right, you have multiple terms here, multiple trigonometric expressions. What you want to do is try to maybe condense it into a single expression, maybe no pluses or minuses if possible, no fractions or anything like that, right? You're trying to make it as simple as possible. Okay, so the first thing that we would do for something like this one, notice that there is a sine and another sine, right? One thing that you could do is take out a GCF. All right, so the first thing that I would do is, again, take out a GCF. All right, so when you take out a GCF, we get sine of x is cosine squared x minus 1. All right, you took out a sine from here, and you took out a sine from here. Right, we get sine x times cosine squared x minus 1. All right, now another thing that you can do is the cosine squared x minus 1 should stand out to you, right? You would use now a Pythagorean identity. A Pythagorean identity, right? Identity. Now, if you remember, right, and we're going to give you this little sheet anyway, right? The sine squared x plus cosine squared x equals 1, all right? So what does that mean you could do? Well, there are actually a couple ways that you could go about it. Why don't we try replacing this cosine squared x with something in terms of sine, right? Because we see a sine out here, maybe that'll make it a little bit easier. So why don't we subtract sine squared x on both sides? All right, and then that gets rid of this over here, and then we get cosine squared x is 1 minus sine squared x. All right, so then what does this give us? This gives us sine of x times 1 minus sine squared x minus 1. All right, how does that help us, right? You just simplify now, right? 1 minus 1 gets you 0. So what you're left with is a sine of x times a negative sine squared x. And then all you have to do from here is just multiply. Sine times sine squared is sine to the third, and then we have a negative. So it is negative sine to the third x. And then this is our simplified expression. I would say we're done here just because we have one singular trigonometric function. It's sine. And there's no pluses or minuses, right? Our final answer is negative. That's fine. But it's as simple as we can make it. All right, let's try something similar here. All right, why don't we try this one a slightly different way, right? We know that we can factor out a cosecant squared x. I'm sorry, not a cosecant squared, just a cosecant of x, just because we just did that, right? So we get cosine squared x minus 1, all right? We kind of did before. I mean, I rearranged it so I could replace the cosine squared x, but why don't we try replacing this entire thing, right? Sometimes we can do it a lot easier in one go, right? So I know sine squared x plus cosine squared x equals 1. Let's try to get a cosine squared x minus 1 from this identity here. And what we can do is we can subtract 1 on both sides. That cancels it out here. And then we can subtract a sine squared x on both sides. All right, and then what we're left with is a cosine squared x minus 1 equals a negative sine squared x. All right, so what am I going to do now? I'm going to replace this entire thing with a negative sine squared x. All right, and then we still have that cosecant of x out front. All right, so it does look a little bit simpler, but it doesn't simplify as nicely as the previous one did. So that means what I would do from here is I would change everything in terms of sine and cosine, right? Once you think you got some progress and you're kind of stuck at some point, right? See if you can change anything in terms of sine and cosine. And we can here. We know that cosecant of x is the same as 1 over sine of x. And when you do 1 over sine of x times negative sine squared of x, all right, a sine squared and a sine cancel, and you're just left with a negative sine of x. And so that's your final answer here. All right, there's nothing more I can do to that. That's as simple as it gets. All right. So now let's try something like this one. Your approach is going to be different per problem, right? I know if you're seeing this for the first time, it's probably super confusing, but with practice, with time, should get much better, right? This isn't one of the things that you can just see it once and you'll get it. You have to actually try over and over and over again to really solidify the material, all right? So let's try something similar here. Well, not really similar, right? This is a different kind of problem. But what we can do is there's no pluses or minuses. There's nothing that they have in common. I can't really take out a common factor. So why don't we just start by changing everything in terms of sine and cosine? I know that secant is the same as 1 over cosine of theta. I know that cotangent is the same as cosine over sine. And then there's nothing really that I can do with sine, so I'm just going to leave it as sine. I see a bunch of fractions, though. I'm going to put it over 1. All right? And then what happens from here is that you notice that things start to cancel out. There's a cosine on the bottom, cosine on the top, a sine on the bottom, a sine on the top. This whole thing just simplifies to 1. All right? And it doesn't get simpler than that, right? So we could just leave it alone. All right? Now, if you look at this next one, I have a cotangent squared x times 1 plus tangent squared. This should also give you some clue as to what to do, right? You don't really want to immediately change everything to sine and cosine. But what you can do is maybe use an identity, right? I see squareds, right? There's a square here and a square here. That's some indication that you can probably use a Pythagorean identity. And a pretty simple one that we can use is we know that 1 plus tangent squared x is secant squared x. So I have right now cotangent squared x times secant squared x. All right, and then just looking at these by themselves doesn't really simplify to anything nice. So if it looks like it could simplify further, but it doesn't, maybe change everything to sine and cosine. Right, we have that cotangent squared x is the same as cosine squared x over sine squared x. And then secant squared x is the same as 1 over cosine squared x. All right, and then notice now the cosine squared x's cancel out. You're just left with 1 over sine squared x. And then once you simplify this, right, it looks like it's already pretty simple, but you can make it a little bit simpler by making it not into a fraction, right? And we know that 1 over sine, we can move sine to the top and make it cosecant. So I have right now that this is cosecant squared of x. All right, and that's as simple as it gets. All right. So this next page, it says simplify by factoring. In a lot of cases, you're not really going to be able to simplify by factoring. A lot of times the directions are just going to say to factor, right? Because you can't really simplify by factoring, right? They're kind of opposites. But let's kind of use the same factoring techniques that we already know how to do and just apply them to trigonometric functions, right? So let's look at this first one. It might not look super obvious, but there's something squared minus something squared. All right, let's say I had given you guys on a test or a quiz something like x squared minus 1. All right, that would be a gift to you guys, right? You guys know that this is x plus 1, x minus 1. It's a difference of squares, all right? Now, notice that this is kind of the same thing. I have something squared minus 1, so all I can do, there's a minus in between, it's a difference of squares. This is the same as secant of x plus 1. And then secant of x minus 1. And then that's as factored as it gets, so we would just leave it alone like that. All right, let's try the same exact thing. Let's try the one underneath it, actually. Notice that this also looks like a difference of squares. I have a 1 minus something squared, right? So again, it's going to be our difference of squares pattern. It's going to be a 1 plus, 1 minus. Square root of 1 is 1. Square root of cosine squared is just cosine of x. All right, and then this is as factored as it gets. All right, nice. Now, if you look at these next two, number 6, number 8, looks a little different than the ones that we just did, but think of it like a little substitution, right? You can do something like 4u squared plus u minus 3, right? That just looks like a normal quadratic. This is the form that we're looking at right now, right? I have 4 times something squared plus that same something minus a constant. You can treat this just like a quadratic expression, right? So let's factor it the exact same way. Let's do 4 times 3, so negative 12. So let's factor this as follows, right? So we get tangent squared x plus tangent of x minus 12. Right, and then factors of negative 12 that add to a positive 1, all right, are positive 4 and negative 3. So then what we're left with is a tangent of x plus 4, and then a tangent of x minus 3. All right, because we multiplied by a 4, let's divide each number by 4. So then we get tangent of x plus 1. And then 3 over 4 doesn't simplify. Let's slide that 4 out front. So we get 4 tangent of x minus 3. All right, and then that's as factored as it gets. All right, we can try the exact same thing with the next one. The next one also looks like a quadratic. So let's factor it as such. All right, let's do 2 times 6, and we get 12. So we get cosecant squared of x minus 7 cosecant x plus 12. All right, so factors of 12 that add to negative 7 are -4, -3. So we're going to get a cosecant of x minus 4, a cosecant of x minus 3. All right, but I can't leave it like that. We had a number in front. It was a 2. So let's divide both of these by 2. 4 divided by 2 is 2, so we get cosecant of x minus 2. And then slide this 2 off front. This is going to become a 2 cosecant of x minus 3. All right, and that's as factored as it gets. All right, so same factoring techniques that you guys are used to. We're just applying it to trigonometry now. All right, notice that these kind of look the same as what we just did. Your instinct is going to be to factor it just the way it is, which perfectly fine. I mean, that makes sense. It's just there's an issue when you try to do that. Notice that number 9, we see a cosecant and then a cotangent. All right, we can't just factor it the way it is, just because this is the same as if we had something like, I don't know, y squared minus x minus 3. All right, y and x do not go together, so you cannot factor it just the way it looks. But thankfully, this isn't something like that, because we can change cosecant to be in terms of cotangent. All right, we know that based on one of our identities, this is the same as 1 plus cotangent squared x. All right, and then when you do this, just bring the rest of it down, combine like terms. I have a 1 minus 3 is going to get you a -2. So we have cotangent squared x minus cotangent of x minus 2. And then from here, just factor it like normal, right? Factors of -2 that add to -1 are a -2 and a +1. So we get a cotangent of x minus 2 and a cotangent of x plus 1. All right, and that is how we factor an expression like this. And I'm sure you can guess we can do the exact same thing here. All right, so this secant squared x we can change to be 1 plus tangent squared x. All right, and then you get plus 3 tangent of x, right? Just bring everything else down, plus 1, and then combine like terms. 1 plus 1 is 2. So then we get tangent squared x plus 3 tangent of x plus 2. And then factors of 2 that add to 3 are just 2 and 1. All right, so this is tangent of x plus 2. And then we get a tangent of x plus 1. And then that would be our final answer. All right, there's nothing more we can do with those. All right, now we're back to simplify. All right, these are a little bit trickier than some of the other stuff that we have done before, but you're going to see they're actually pretty cool in the end. All right, so if you look at this first one, it kind of starts off fairly simple. We get a sine of x plus cotangent times cosine, right? But there's no GCF or anything, right? There's nothing that we can take out. I don't see anything squared. We can't really use a Pythagorean identity. So what we do instead is let's just jump into changing everything in terms of sine and cosine, right? And that's always what I would suggest to you guys if you're stuck, right? If you genuinely see nothing, no common factor, no Pythagorean identity, none of that, change everything in terms of sine and cosine. So I have that this is sine of x plus cotangent is the same as cosine of x over sine of x, and then times cosine of x. All right, and then what that does is it gives you sine of x plus cosine squared x over sine of x. All right, now there are a couple different ways that you could go about it from here. I'm going to show you what I would do, and that is make everything into a single fraction. All right, I think the next example, number 12, is very similar, so I'll show you a slightly different way to do it there. But for this one, let's just make everything the same fraction, right? So I have that this is over sine of x, and then sine of x is over 1. So to get a common denominator, I'm going to multiply the top and the bottom by sine of x. All right, and then that's going to get you sine squared x plus cosine squared x over a common denominator of sine of x. Now, the top should look very familiar to you now, right? The top should be a Pythagorean identity, right? So that means this entire thing is going to simplify to 1. So it's going to be 1 over sine of x. All right? And now we can make this a little bit simpler by making it not into a fraction, all right? And this entire thing just very simply becomes cosecant of x. All right? Pretty cool stuff, I think, right? You took a very seemingly harmless expression, made it a little bit more complicated, and then you finally simplified it into something really, really nice. All right? So, I don't know. We'll try the exact same thing with the next one. All right, you guys probably think I'm crazy when I say that, but I think it's kind of cool, right? I think it's pretty nice to simplify something that, I don't know, looks like it could be a little bit more complicated than it is, and then you realize using some identities it simplifies really nicely, right? Anyway, let's try the same thing with this one. All right, so again, maybe change everything in terms of sine and cosine, right? There's no common factor here. So what we can do is we can make this a 1 over sine of x minus the cosine is going to be a cosine of x times cotangent is going to be cosine of x over sine of x. All right, and then this is going to get us 1 minus cosine squared x over sine of x. All right, and then this looks like it could be an identity. All right, so remember, the identity that we're using is going to be the sine squared x plus cosine squared x equals 1. All right, so how can we get a 1 minus cosine squared x from this identity? Is we're going to subtract the cosine squared x. So minus cosine squared x on both sides. And then we get rid of this right here. So we have that 1 minus cosine squared x is the same as sine squared x. So then this is going to very simply become sine squared x over sine of x. And then we have 2 signs on top, 1 on the bottom. We're very simply just left with 1 sine of x. All right? So we took an expression, made it a little bit more complicated in the middle, and then finally it simplified pretty nicely. All right? So let's try the same thing with this next one. All right, again, the goal here is to simplify, and it looks like we're starting with a very complicated expression, right? I have a fraction plus another fraction, and they don't have the same denominator. So what you want to do, and what your instinct should be in all of these kinds of problems, is to give it the same denominator, right? So why don't we try that, right? Let's write everything over a 1 plus cosine of x times the sine of x. So 1 plus cosine of x times sine of x. All right? Now, what we would do is the top would become, the top of this one then, it has a 1 plus cosine of x. So what I'm going to do is I'm going to do a sine of x times sine of x just to get this on the bottom, right? I want that on the bottom. So we're going to be left with a sine squared x. All right? Do the same thing with this one. This one has a cosine, this one has a sine on the bottom, but it's missing the 1 plus cosine. So I'm going to do times 1 plus cosine on the top, and then we can distribute the cosine of x, and then this is going to give us plus cosine of x plus cosine squared x, right? And then what should stand out to you are the squareds, right? Anything squared should give you some indication that you're going to use an identity. And in this case, a sine squared x plus a cosine squared x, that whole thing just equals 1. All right, so that means this entire fraction just simplified, or at least the top of this fraction just simplified to 1 plus cosine of x over 1 plus cosine of x times sine of x. And then now hopefully you see the 1 plus cosine of x cancels out, and then we're just left with 1 over sine of x, which 1 over sine of x, we can make that a little bit simpler, and this is going to become cosecant of x. All right? So it shouldn't be too bad, right? Looked pretty complicated in the beginning, did some basic algebra stuff, and it made it very nice and simple. All right? Let's try the same thing here. All right, so I have a 1 plus and a 1 minus sine of x on these denominators. So what we're going to do to get a common denominator is multiply both of them. I'm going to have a 1 plus sine of x and then a 1 minus sine of x. All right, to get that from this first fraction, we're going to have to multiply by a 1 minus sine of x. All right, and then what does that get us? That gets us a 1 minus sine of x on top. All right, same thing with this next one. We have a 1 minus sine of x, but it's missing the 1 plus cosine of x, so I'm going to have to multiply by 1 plus sine of x. So I have 1 minus sine of x times 1 plus, plus 1 plus sine of x. All right, and then notice that things cancel here, right? Sine of x minus sine of x cancels out, and you're just left with 2. Over the bottom now, hopefully you realize, is a pattern, right? I have a 1 plus sine of x, 1 minus sine of x. That's the same as a difference of squares, right? Or it's one of our special products, right? We can just square the first minus square the second. So I get 1 minus sine squared x. And then looking at one of our identities that we've done a ton already, this entire denominator is going to become cosine squared x. All right, if you can't see that, just look at your identities, try to manipulate it to get a 1 minus sine squared x, and then we get a 2 over cosine squared x. All right, very last thing we can do, cosine on the bottom is the same as secant on top. So this whole thing is just going to become 2 secant squared x, and that's as simple as we can make it. All right, hopefully not too bad, right? Some of these are a little complicated. With time, again, I keep telling you guys, right, with time it shouldn't be too bad. Okay, so now let's try something like this, right? I have a 1 over 1 plus sine of x. Now what we can do to make this a little bit simpler is we want to try to get an identity somewhere, right? It looks like the bottom could be an identity. The only thing that it's missing is a square, right? It's not a 1 plus sine squared x, it's just 1 plus sine of x. All right, so to make it an identity, let's multiply the top and the bottom by something that's going to guarantee that we get an identity. And that's going to be by the conjugate, right? So it's going to be 1 minus sine of x on the top and on the bottom. All right, the top then is going to become 1 minus sine of x. Over the bottom is going to become a 1 minus sine squared x. Alrighty? And then now we know that the bottom, that looks like it's an identity, right? This is the same as cosine squared x. So we get 1 minus sine squared x. Just 1 minus sine of x over cosine squared x. Alright? Now, something we don't particularly like about this right now is the fraction. There are a couple things that we can do is we can turn it into secant, or what we can do is we can split it up into 2 fractions, right? Let's try that instead. So I'm going to split it up into 2 fractions. I have a 1 over cosine squared x minus sine of x over cosine squared x. All right. Now when you do this, 1 over cosine squared x is just secant squared x, and minus sine of x over cosine squared x. It looks like some of that could simplify, right? We have that sine of x over cosine of x is tangent, but then there's another lingering 1 over cosine, right? Just because sine squared over cosine squared would get you tangent squared, but unfortunately we don't have that, right? This is just as good as we can make it right now. All right, I know that sine of x is the same, sine over cosine is the same as tangent of x, and then 1 over cosine is the same as secant of x. All right, and then we have that this is secant squared x minus tangent times secant. And unfortunately, that's as good as we can make it. I mean, there's not really much more that we can do with this. It's about as simple as it gets. It looks like all the fractions are divided out. It looks like we do have a common factor, but there's no need to factor it out. I mean, we were told to simplify it, not factor it. So, right, not the prettiest thing, but as good as we can make it. All right. A good question I get often is, how do you know when to stop, right? I would aim for no fractions. If you can remove any pluses or minuses using a Pythagorean identity, you would do that, but it looks like we couldn't do that in the previous one, so that's how we're going to leave it. All right. Now let's try something similar here. All right, so there's a couple things that you could do, right? You could do the same thing that we just did, or you could change the top to be in terms of sine. All right, I'm going to let you guys figure that part out, but just for the sake of consistency, let's do the exact same thing that we did before. So I'm going to do 1 plus sine of x on the top and on the bottom. And then notice on the top we get a cosine squared x times 1 plus sine of x. Over the bottom, when you multiply this, is going to become 1 minus sine squared x. All right? And we already know that the bottom is going to simplify to cosine squared x. So I have a cosine squared x times 1 plus sine of x over cosine squared x. And then these cosine squared x's cancel out, and you're left with just 1 plus sine of x. All right? And again, that's as good as we can make it. Again, not as simple as some of the other stuff that we've done, but there's really no way to make it any more simple or simpler. Yeah, there's no fractions here. Everything's in terms of sine and cosine. There's no hidden identities that we can use, so that's as good as we can make it. But that's it for this lesson. Again, this isn't the type of lesson you get just from looking at it once, right? You kind of have to try things yourself and kind of explore, right? Because if you aren't trying this on your own, it will be a struggle when you're taking a test or a quiz. But it's an important lesson, right? It helps us with some of the stuff that we're going to do later on when we actually solve trig equations in 7.3. So it's good to know how to do it now.